Dear students, very good evening. Yesterday we have seen some problems under some important topic. It is about multiple integrals. Okay, so there we have discussed about type 1, type 2 and type 3. When both the limits are variables, when both the limits are constants and one of the pair of limits are constants and one of the pair of limits is variables. Okay, and we have clearly seen what are those three types. Okay, today we are going to see some example problems irrespective of their types. Try to understand the problems. Okay, so first you have to understand what is the given problem of, okay, what the type of the given problem. Okay, after identifying them, so irrespective of the type you should be able to solve those problems. Okay, you should be able to solve those problems. So here I shall give some problems for your reference. Okay, so the first problem is, so okay, here you are going to see the first problem. Okay, here you are going to see the first problem. The first problem here in type 1, so here irrespective of type, so we are going to see. So the first problem is evaluate integral. Okay, integral 0 to 1 and 1 to 2, integral 0 to 1 1 to 2, x into x plus y into dy dx. Okay, so this is a given problem. Both the limits are constant, so we can integrate it with respect to x or y first and with respect to other term later. Okay, no problem by this. Okay, integral 1 to 2 and integral 0 to 1. So on multiplication you will get x square plus xy into dy dx. Okay, so here I will get integral 0 to 1, x square dy will become x square y plus x y square by 2. The limits are 2 and 1. For what we have to substitute 2 and 1? For y. For y we have to substitute. So y equal to 2 and y equal to 1 and then dx. Okay, so that is equal to integral 0 to 1. So it will become 2x square plus 4x by 2, this is upper limit, minus you will have the lower limit also, so that is x square into 1 plus this is x into y square, this 1 square by 2. Okay, so this should be integrated with respect to dx. Okay, so now you will get integral 0 to 1, 2x square minus x square will be x square. Okay, x square, then plus 4x by 2 minus x by 2 will be 3x by 2. Okay, 3x by 2 into dx, that is equal to x cube by 3 plus 3x square by 4. Okay, already 1 2 is here. On integrating x you will get x square by 2, so it will become x square by 4. So you will get the following result after substituting the limit 0 to 1, that is 1 by 3 plus 3 by 4 on substituting the upper limit. So after that you have to subtract the values after substituting the lower limit values. So you will get 0 by 3, then 0 by 4, 3 into 0 by 4. So the answer is obtained by taking the LCM between 1 by 3 and 3 by 4. Okay, so you will get 4 plus 9 divided by 12, that is equal to 13 by 12. The answer is 13 by 12. Okay, so this is our first problem. So for you I am giving some problems as homework. Okay, for him giving some problems as homework. Okay, now I am going to give you some more examples. So these problems comes under the type, you have to note it down, these problems comes under the type problems under Cartesian coordinates. Okay, problems under Cartesian coordinates. Okay, why? Because whenever you are having the limits as x and y, okay, x and y, that is called Cartesian coordinate. Okay, so if I told this before, you may not understand what is this. So after solving a problem, you can understand. Cartesian coordinates means very simple, x and y. Okay, then if I want to include something respect to r and theta, okay, r and theta means, then this will be called as polar coordinates. This will be called as polar coordinates. Okay, polar coordinates. So here you will have some radius. Okay, some radius will be there, some angle will be there. Okay, so that is called polar coordinates. Okay, so dear students, you have to understand those things. Okay, so let me tell you some examples. So work out those examples. So before that, what is Cartesian coordinate? Cartesian coordinates means x and y. Okay, and polar coordinates means r comma theta. Okay, and there are some more coordinates also, but like spherical coordinates are there, so but they are not necessary for your syllabus. Okay, you are studying only Cartesian and polar coordinates. Okay, so you are studying x and y and r and theta, and after that in 3 dimension you will be like to study r, theta and phi, but for this part of syllabus you are not required to know about this. Okay, so only Cartesian and polar coordinates are enough. Okay, so dear students, can you take down the problems? So some more examples I would like to tell. Okay, the example is, first thing, evaluate double integral 0 to 2 and 0 to 3 e power x plus y dy dx. So here hint is, you have to split it into e power x into e power y. When differentiating, when integrating with respect to y, x act as constant. When integrating with respect to x, y act as constant. So this is your hint. Okay. Okay. Second problem is double integral 0 to 2 and 0 to 1. Then you are having x y square dy and dx. Okay, so this you have to do, and final problem is in terms of a and b we are going to have. So integral 0 to a, integral 0 to b, then xy into x minus y dx dy. Okay, xy into x minus y into dx dy. Okay, so here sometimes okay, then everything is fine. So dear students, try irrespective of types. I have given a homework because all these are very easy. Okay, all these are very easy, so you have to work out on these problems, and I'm giving 2 more problems also. Here is your fourth problem. So the fourth problem is integral 2 to a and integral 2 to b dx dy divided by xy, dx dy divided by xy. Okay, Okay, so and fifth problem is integral 0 to 1 integral 0 to 1 x square plus y square into dx dy. Okay, into dx dy. So dear students, work out all these 6 problems. Okay, after working out all these 6 problems, tomorrow we are going to see the next type, that is here you can see both as constant elements. So tomorrow we are going to see x as the function, one as the function and another one as the variable. Okay, I mean sorry, one as the constant and another one as the variable. Okay, if it is so, then how to integrate such problems and how to integrate and how to solve those integrals. So those are the areas tomorrow we are going to discuss. I hope you all understand the problem. Thank you all for watching this video. Thank you all once again. Okay.